Sorry. The Subcommittee on Space will come to order. Without objection, the Chair is authorized to declare recesses of the Subcommittee at any time. Welcome to today's hearing entitled An Overview of the National Aeronautics and Space Administration Budget for Fiscal Year 2018. I now recognize myself for 5 minutes for an opening statement, concrete proof of the bipartisan and bicameral commitment to NASA. This budget reflects administration's commitment to the continuity of purpose described in the recent authorization, honoring our commitments in space and maintaining a balanced portfolio are the surest ways for us to enjoy the full benefits of our space investments. The numbers in this request are lower than the amounts in the enacted budget, which causes some concern. However, the preliminary budget blueprint was released before congressional appropriations. Therefore, the lower request does not necessarily reflect a reduction in administration support for NASA. In fact, the current request is in line with recent levels appropriated by Congress. This goes a long way to fixing problems that have plagued NASA programs over the last 8 years. This budget request is refreshing in that it does not propose slashing priority programs year after year. This will allow NASA managers to execute programs in an efficient manner. I want to reiterate the committee's commitment to NASA's long-term goals as described in law. Mars remains the first interplanetary destination for humanity. NASA is encouraged to carry out any necessary intermediate missions, particularly to the Moon, provided that those missions advance future interplanetary exploration. Closer to home, the future of the International Space Station is a top concern. Currently, the ISS will operate until 2024, but the role of the ISS beyond 2024 must be addressed soon. Similarly, I'm also interested in understanding what NASA's plans are for future space suit work. Turning to NASA's scientific exploration, this budget request restores balance across NASA's science portfolio and supports critical work across the entire Science Directorate. Work continues on the James Webb Space Telescope, which I am very proud to say is currently in our home district at the Johnson Space Center for testing, where I was yesterday, along with Acting Administrator Lightfoot and our chairman of our main science committee, I'm very proud to say, along with the Vice President of the United States, meeting our 12 new astronauts of the class 2017. But back to the budget. The budget supports a range of small, medium, and large science missions, including the flagship Europa Clipper and Mars 2020 rover missions. During the Obama administration, the pipeline for outer planet missions was allowed to run dry. This budget returns support for a robust planetary exploration program, which is a national priority. U.S. leadership in space science is critical. On space technologies like laser communication, in-space propulsion, and power systems will allow human exploration to complement the robotic exploration of Mars and other celestial bodies. NASA has many exciting projects and missions across its portfolio. Indeed, NASA may be on the threshold of one of the greatest inflection points in the history of space exploration. Soon, SLS, Orion, Dragon 2, and Starliner vehicles will take their first flights. The James Webb Space Telescope will see its first light. Human presence in low Earth orbit is maturing, and the ISS will begin evolving to the next phase of its life. And soon NASA will begin construction of the Deep Space Gateway, the first permanent human outpost beyond low Earth orbit. Of course, this era of excitement will also be a time of high risk, but with congressional and administration budgetary and political support, the next decade could very well mark a new golden age of space exploration. And I want to thank Acting Administrator Lightfoot for his testimony and look forward to his discussion. And now I'd like to recognize the ranking member, the gentleman from California, Mr. Barra, for an opening statement.
Thank you, Mr. Chairman. Good morning and welcome to Acting Administrator Lightfoot, and thank you for your dedicated service to NASA over the many years. You know, the fiscal year 2018 proposal for NASA is $19.1 billion, a nearly 3% reduction from last year's fiscal year budget. And you know, in the context of the overall federal budget, $19 billion does suggest a recognition of the importance of NASA, and both from the administration perspective as well as ours. But there are a few things that give me pause when I look at the detail of the budget. Part of our goal, being a child of the space race, is education and inspiring that next generation. And one thing that I do worry about is the cut in the education budget, and certainly want to hear from Administrator Lightfoot how we might go about continuing to inspire that next generation, our children, and that next generation of astronauts, especially at such a vibrant, exciting time with regards to space. When we think about the multiple missions, when we think about human space travel potentially to Mars and back again, when we think about the existential questions like the search for life, are we alone, and what does that look like? The rapidity by which we are discovering planets that potentially could house life. The chairman talked about the missions going to deeper space. We live. I thought the second half of the 20th century was a super exciting time for space, but I truly believe the coming decades are going to be much more exciting. You're seeing the rapid entry of the private sector into space, the commercialization of space, the amount of venture money that's going into space, and I truly believe this has the ability of inspiring the next generation of scientists, of engineers, et cetera, as they see that. And want to make sure we continue that. I also do, there's about a 9% cut to NASA's exploration budget. That does give me a little bit of pause as well. Again, at a time where I think we've got to continue U.S. leadership in space. Space in the 21st century will be an international endeavor as other countries get engaged. That said, I still think U.S. leadership and American ingenuity with regards to space is going to be incredibly important. The last thing is, as we look at the multiple missions, what we discover in space also helps us understand our own planet much better, and Earth. And I do want to make sure that the Earth Sciences mission is also protected. NASA obviously has a critical role in the Earth Sciences mission, and certainly want to hear from the acting administrator. That said, NASA is a source for many of us of national pride. It is certainly something that we think leads the way, and I think NASA also, as we look at international diplomacy, how we work with other countries around the world, space, and the International Space Station is a model example of how the world can work together, especially as these discoveries are not just for the United States, they're for all of humanity. So with that, I look forward to hearing from Mr. Lightfoot, and I'll yield back.
Thank you, Mr. Barra. I now recognize the chairman of our full committee, Mr. Smith from Texas.
Thank you, Mr. Chairman, and welcome, Acting Administrator Lightfoot. As the Chairman Rabin said a minute ago, it was good to see you at Johnson Space Center yesterday. I'm still amazed that you got up here in time to be at this hearing today. Mr. Chairman, this committee has consistently demonstrated that U.S. leadership in space is a bipartisan priority. The 2017 NASA Transition Authorization Act, signed into law in March by President Trump, is a clear demonstration of that. A key concept in the current NASA authorization is continuity of purpose. Over the years, erratic direction and changes in mission have repeatedly led our space exploration effort astray. The fiscal year 2018 NASA budget shows that Congress and the administration both support a consistent, focused space program. The amounts requested in this budget for not only the Space Launch System and Orion crew vehicle and the commercial crew and cargo programs reflect this. These requests are much closer to past appropriations and are realistic and reasonable, providing an increased level of stability and continuity of purpose for two of NASA's main initiatives. This year's Authorization Act also declares that NASA's goals include extending human presence throughout the solar system. Accordingly, NASA continues to focus on Mars as its first interplanetary destination for human exploration. NASA should conduct missions to intermediate destinations on the way to Mars, such as the Moon, so long as those activities support subsequent journeys to Mars and beyond. Previews of NASA's Deep Space Gateway program architecture have given us a peek at NASA's plans. We look forward to reviewing the human exploration roadmap on how NASA plans to pursue its human space exploration goals in coming decades. It's good to see that NASA budget request ends the previous administration's ill-conceived asteroid mission. The 2017 NASA Transition Authorization Act clearly reflects the concerns of both Congress and NASA's Advisory Council about the utility and cost-effectiveness of that mission. Instead, other and more needed technologies will be developed under different programs. Likewise, within the Science Mission Directorate, the budget promotes a much better balance among NASA's many scientific endeavors, especially for planetary science. And it starts to reverse the significant growth in Earth science. The Obama administration's fiscal year 2017 Earth science request was 42% higher than its request for planetary science, and that's 75% higher than the amount requested for Earth science in 2007. As a reminder, there are many other federal agencies involved in Earth science research, but only one agency that promotes space exploration. This budget reflects the idea that while NASA can continue to develop state-of-the-art Earth sensing programs, it is not a piggy bank for funding climate activities already addressed elsewhere in the federal government. The James Webb Space Telescope, which I saw under construction yesterday at Johnson Space Center, continues on budget and on schedule after NASA and Congress worked to correct for overruns and delays. We continue to expect a launch in October next year. NASA science supports other activities too. The Transitioning Exoplanet Survey Satellite and the Wide Field Infrared Space Telescope will increase our understanding of exoplanets. And I want to emphasize that the recent authorization bill directs NASA to, quote, search for life's origin, evolution, distribution, and future in the universe. The James Webb Telescope, Wide Field Telescope, and Exoplanet Survey Satellite will certainly advance this priority. Congress has the responsibility for setting the top-level direction and missions for NASA and has done so with the 2017 NASA Transition Authorization Act. NASA is responsible for providing a compelling plan and executing it. Now that we have received the budget request, it is Congress's next responsibility to ensure NASA's budget is prioritized and funded. Of all the non-defense, non-security agencies in the federal government, NASA received the most favorable proposed budget, and I am sure that this committee will continue to support American leadership in space. Thank you again, Mr. Chairman, and yield back.
Thank you, Mr. Chairman. The ranking member of the full committee is not here yet, so we're going to go on to introductions of our guests. Mr. Robert M. Lightfoot, Jr., our witness today, Acting Administrator of the National Aeronautics and Space Administration. His permanent title is Associate Administrator for NASA. Before serving as Acting Administrator, Mr. Lightfoot was Director of NASA's Marshall Space Flight Center in Huntsville, Alabama, where he managed propulsion, scientific, and space transportation activities. From 2003 to 2005, he served as Associate Administrator for the Space Shuttle program in NASA's headquarters right here in Washington, where he oversaw technical and budgetary oversight of the annual budget and initial transition and retirement efforts for the space infrastructure, for the shuttle infrastructure. From 2005 to 2007, Mr. Lightfoot was responsible for overseeing the manufacture, assembly, and operation of the primary shuttle propulsion elements, such as the main engines, solid rocket boosters, and the reusable solid rocket motors. Mr. Lightfoot received a bachelor's degree in mechanical engineering from the University of Alabama. He was also named Distinguished Departmental Fellow for the university's Department of Mechanical Engineering in 2007 and was selected as a University of Alabama College of Engineering Fellow in 2009. And I would like to recognize Mr. Lightfoot for 5 minutes to present his testimony.
All right, thank you, Mr. Chairman. It's great to be here. I want to thank you and Chairman Smith for being in Houston yesterday. It was a very exciting event, and we appreciate your support.
Absolutely.
Of the team. Mr. Chairman and members of the committee, I'm pleased to have the opportunity to discuss NASA's FY18 budget request. We appreciate the committee's support and especially your bipartisan commitment to the constancy of purpose for NASA. The Transition Authorization Act for 2017 and the Consolidated Appropriations Act for 2017 are concrete contributions to this vital continuity, and we appreciate the committee's hard work on NASA's behalf. NASA's historic and enduring purpose can be summarized in 3 major strategic thrusts: discover, explore, and develop. These correspond to our missions of scientific discovery, missions of exploration, and missions of new technology development in aeronautics and space systems. NASA is focused on these missions, but we never lose sight of the other contributions that our unique achievements make possible. NASA's missions inspire the next generation. They inject innovation into the national economy. They provide critical infrastructure information to national challenges, and they support global engagement and international leadership. The FY18 request of $19.1 billion supports a vigorous program that leads the world in space and aeronautics. And while we had to make some difficult decisions with regard to earth science and education, this remains a great budget for NASA. With this budget, we will advance U.S. global leadership in aeronautics by developing and transferring key enabling technologies. In FY18, we'll award a contract for detailed aircraft design, build, and validation of a low-boom flight demonstrator. This low-boom X-plane will demonstrate quiet overland supersonic flight, opening a new market to U.S. industry. NASA will also use 20 spaceborne missions to study the Earth as a system. The request supports 2 new missions by the end of 2018, the GRACE follow-on mission, which will track water across the planet by precisely measuring Earth's gravitational field, and ISAT-2, which will measure ice sheets, clouds, and vegetation canopy heights. We supply Earth science data for weather forecasting, farming, water management, disaster response, and even disease early warning. In September, Cassini will make a final series of 22 daring dives through the 1,500-mile wide gap between the planet and its rings as part of its grand finale end-of-mission maneuvers. The OSIRIS-REx mission will conduct a search for elusive objects known as Earth Trojan asteroids on its journey to the asteroid Bennu. We'll also launch Mars Insight Lander in 2018 to study the interior structure of Mars, and we're on track to launch the next Mars rover mission in 2020. James Webb continues on schedule for its 2018 launch. That'll be our next giant leap forward in our quest to understand the universe and our origins. NASA's Transiting Exoplanet Survey Satellite, or TESS, will launch in 2018 as well, extending the pioneering discoveries of the Kepler Space Telescope. In heliophysics, we'll also launch the new recently named Parker Solar Probe on a mission to fly closer to the Sun than any previous mission. That'll join 18 other missions that are dedicated to studying our closest star. It's vital that NASA continues the investment in transformative space technology. In 2018, we'll continue work in deep space optical comm, high-power solar propulsion technologies, and advanced materials. The International Space Station, our first step on the road to deep space exploration, is delivering the knowledge and technology we need to keep astronauts safe, healthy, and productive on deep space missions of increasing duration. Working with our commercial crew partners, NASA plans on returning crew launch capability to American soil in 2018. We'll also continue the development of the SLS rocket, the Orion crew capsule, and the ground systems, and the technologies and research needed to support and deploy critical life support and habitation capabilities, leading to crewed missions beyond the Earth-Moon system. In 2019, we'll plan a launch of the uncrewed Exploration Mission 1 using the new Heavy Lift Launch Vehicle, SLS, and Orion on a mission to lunar orbit. Shortly after that, no later than 2023, we'll have a crewed mission of EM2. With your continued support, we look forward to extending human presence into deep space, exploring potential habitable environments around the solar system, and deepening our understanding of our home planet. We look forward to pushing our observations of the universe back to the time when the first stars were forming and opening the space frontier. While the future benefits of discovery are always difficult to predict, we are confident that the resources we are requesting represent an investment that will deliver significant return to the nation. Mr. Chairman, I'd be pleased to respond to your questions and those of other members of the committee. Thank you.
Thank you, Mr. Lightfoot. I appreciate it. Thank you. The chair recognizes himself for 5 minutes for questioning. And again, thank you for being here. We really appreciate you. The GAO recently found that both of the commercial crew contractors are likely to be delayed into 2018 into 2019. Under normal contracting mechanisms, there would be a penalty associated with not meeting schedules. My understanding is that under these contracts, the penalty is simply not receiving payment until the work is completed. GAO also recently found that the SLS and Orion programs would also face schedule delays. Conversely, under those contracts, my understanding is that the contractors could face the loss of award fees. Can you explain which model provides the government the best tools to procure a system or service in the most timely and least costly manner?
Yes, sir. Great question. We have both groups continue to make great progress, and we've got when we did the commercial crew program, we tried a new acquisition strategy approach with fixed price contracts, where when they slip, we do simply just pay when they make their milestones. We have had success with both processes. If you look at TDRS, which we fly today, it was a fixed price contract as well. And what we do internally in the agency is we make an assessment from an acquisition perspective, which way is the best way for us, depending on the amount of development. If it's a lot of development, we feel like cost plus is a way to go because we may not have the perfect requirements nailed down. We felt pretty confident in our requirements when we went to the commercial crew guys, and we felt we could go fixed price. So that's really how we assess it. We have what's called an acquisition strategy process that allows us to make an assessment which way we're going to go as we move forward. So that's how we did this one, and we think both are options that we should always consider when we do these.
Yeah. Okay. Thank you. And then regarding science, the decadal process plays a significant role in how NASA prioritizes and how Congress funds scientific missions. This budget proposes cancellation of several Earth science missions that were never recommended by the decadal process, specifically PACE, OCO-3, RBI, and Discover, EPIC, NISTAR, and NISTAR instruments. With the next Earth Science Decadal Survey forthcoming, the request also rightly proposes cancellation of the Clario Pathfinder. Clario could potentially cost in excess of $5 billion, and it is in the earliest stages of development. Decisions about the mission would be well served by more information from the community. All of this begs the question, why were we funding missions that were not prioritized by the decadal process?
Well, Mr. Chairman, we have always looked at the decadal process as our guiding principle from that perspective. But there's other things we can do outside of the decadals. When we got the budget for this year, for the 2018 budget, we went back to our principles of decadals, and we said we used a kind of a three-tier process. We said, what's in the decadals? What gives us the best science value for return for what we're doing, and then how are they performing? So some of the issues like RBI, we were having some performance issues associated with that. And so that's how we came up with the list of the ones that we proposed coming back to you guys for the FY18 budget.
Okay, and Mars is often referred to as a horizon goal for human space exploration. However, if we are careless in our planning, Mars exploration could become unsustainable, perhaps even a dead end. So how would the Deep Space Gateway make exploration of Mars more sustainable and help NASA to achieve its mission of extending human presence throughout the solar system?
We believe that what we need is an infrastructure throughout from low Earth orbit to get to Mars. We're going to need some infrastructure along the way. And the Gateway concept, which is just a concept at this point, actually provides us kind of a stepping stone approach, and we figured that's the better way to do it. If you go from you take it one step at a time, we think we can actually get there in a more efficient way. It also gives an opportunity for public-private partnerships to come into play, and we think there's a good mix that we can do. And if you do it in this stepping stone way, you're not committing to the final answer at first. You're doing it in a pretty measured way that I think is consistent with the budgets that we have.
And one last question. The administration has expressed interest in public-private partnerships. When used appropriately, funded Space Act agreements are a useful tool to advance partnerships. NASA's current policy limits the use of funded Space Act agreements to cases where contracts, grants, and cooperative research and development agreements cannot achieve agency objectives. This ensures that there is proper oversight of the use of funded Space Act agreements. Does NASA intend to keep this policy in place?
Yes, sir. We think we use the entire suite of tools we have for acquisition, and I think we'll keep that policy in place.
Okay, thank you very much. Now I'd like to recognize the ranking member of our subcommittee, Mr. Barrow.
Thank you, Mr. Chairman. Just continuing on Chairman Babin's line of questioning, with Mars as a longer goal and thinking about that, I'm looking at the budget for space launch for SLS and the Orion crew vehicle, and it does look like it comes in for Orion about $164 million under fiscal year 2017 budget, as well as $212 million for SLS relative to fiscal year 2017. How does this impact our ability to get to Mars if our goal is still, as many of us on this committee have said, by 2033? So.
Yeah, I think the budget we've proposed has got the systems we need in 2018 to keep making the progress we think we need to make on all the different systems we have. Clearly, we think we're going to need something commensurate with inflationary growth or economic growth going forward as we move forward. But for 18, for this budget, we think we'll make the progress we need to make on all the systems to get us to our goals of the Moon and Mars down the road.
So, and also, there's a proposed termination of the asteroid redirect mission. Part of the thought there was also, when that mission was in place, was the next generation of propulsion systems, particularly solar electric propulsion. I'd be curious, with the proposed termination of that mission, how's that going to impact solar electric propulsion?
Yeah, this budget keeps solar electric propulsion in there. One of the things that we discovered in the work on the asteroid redirect mission is that's a pretty big enabler for us on some of the things we can do, especially in the infrastructure we're going to need around the Moon.
Right.
So we're proposing to keep that and probably, so we'll continue to develop in that in space technology and use it as part of something like a power propulsion bus that we'll use around the Moon as the core for some of the infrastructure we need.
So you'll continue to work in that direction.
Yes, sir.
You've got the resources. And then the last thing, in my opening comments, talked about the importance of inspiring the next generation of astronauts, our kids and grandkids. How does NASA, again with the current budget that's being proposed for the coming fiscal year, propose to continue its education mission?
Yeah, so we've been working on that for a while with internal to the NASA in terms of the better way to actually deploy our educational activities that we do in a more efficient way. So that was one thing we were working before this came out. The other thing that we truly believe is that our entire budget is for inspiring the next generation. I mean, if you think about yesterday's event with the astronaut candidates, I mean, it was just really awesome to see the excitement around that and the excitement it generated. The emails I've gotten today from just people I know, public I know that said, this is really neat. That wasn't an education event. That was us talking about our missions. And I think our missions are what inspire people, and I think that as long as we're doing the missions we're doing, we'll continue to inspire that next generation.
And do you feel within the current budget you'll have the ability to go out to schools and continue to do some of that direct education stuff?
Yeah, what we've done is we've got a baseline services activity we're doing inside the agency to better sync up our education activities with our outreach activities, so make sure they're better aligned when we go out. We absolutely think we'll continue those activities. Okay.
And then also, obviously, these are multi-year missions, multi-year strategic planning. As we're looking at longer-term goals, the chairman brought up the International Space Station, and we've committed to funding through 2024. Obviously, that one thing we've certainly been meeting with folks, chatting with folks at NASA as well as others, the potential possibility, as more commercial entities get interested in space, as other institutions see this valuable asset, and the academic sector and others, the potential of life after 2024. And I'd be curious, in NASA's long-term planning, how are you guys thinking about the ISS in longer term?
Well, as you said, we're approved till 2024.
Right.
And what we're working on now is what are the transition indicators, as we would call them. There's very technical reasons you can go into that, science, technologies we can do, but there's also the question of that is a destination for a lot of folks, other than just us, and it's an enabler, frankly, of the commercial industry. So we're looking at that now. We're not planning on going past 2024, but we're actually talking about what would it do. And I think as a policy for the United States, we have to decide whether, it's a symbol of our leadership up there too, right?
Well, now's the time to do that planning, right? So
Yep,
we don't start that conversation in 2023.
Yeah, agree.
Great. Thanks. I'll yield back.
Thank you, Mr. Bear. I now recognize the chairman of the full committee, Mr. Smith from Texas.
Okay. Thank you, Mr. Chairman. Mr. Lightfoot, I've already commented on the budget. So let me ask you some general questions, but let me preface them by pointing out the obvious, and that is the American people are absolutely fascinated by space. They're fascinated by space exploration. They're fascinated by the night sky. I think there is a real good reason why the Air and Space Museum here in D.C. is the most popular museum in America. It's not an art museum in California. It's not a history museum even in D.C. It's the Air and Space Museum. And we had an indication of interest in our space program yesterday when we were at Johnson Space Center. And we had twice as many people as ever before apply to be an astronaut. And it is absolutely incredible to me. We had 18,000 applications for 12 spots. And that comes out to, I think, 1 to every 1,500 applications. Probably the hardest job to get in America without any question. But on the other hand, they are our real heroes today and will be tomorrow. When we think about space exploration and how inspired the American people are by it, another example would be the discovery of what in just the last 12 years of 3,500 exoplanets, several dozen Earth-like planets. So people, and every time there's any kind of discovery in space, it makes the front page of the papers, it leads the news at night and so forth. But my general question is this: what do you think are the most exciting things happening in space today? What is going to seize the imagination of the sixth grader walking to school or the adult in their homes?
Well, I think you kind of nailed it with your preface there. To me, I think there's anything that we do with humans is one piece of that. When you can actually see another human doing something in space, it really is in our DNA to explore, and I think people feel part of that. But on the science side and the aeronautics side, if you look at the discoveries we're making from a science standpoint, when we found TRAPPIST-1, the 7 exoplanets, potential exoplanets around the star, 4 billion hits in our social media, 4 billion in all our different platforms that we have. That's incredible. I mean, that's the kind of reach and interest that people have in what we're doing. And I think it's just the fact that people they're inspired by anything we discover, right? Because you're challenging things that we thought we knew. And I think that's so as long as we're doing the good missions and the big missions like we're talking about, I think the inspiration will be there.
Okay, good. Let me ask you a more specific question and a leading question, and it's a subject that I'm fascinated by. And that is that sometime, maybe in the next 5 to 10 years, we're going to have the capability of analyzing the spectra of Earth-like planets and being able to determine, for example, whether there is methane or oxygen in the atmosphere, and if so, that is very strong evidence that there is something alive on the surface. It may be vegetative, it may be sentient, we don't know. But what do you think we might discover over the next few years that will possibly be the biggest space news in a century?
Wow. We'll see. From my crystal ball perspective, I think really I don't know what that discovery will be. I don't think 10 years ago I could have told you we would have had 3,500 exoplanets, right? But I think what we're doing is we're working on the systems that allow us to make those civilization-level discoveries, the kind that really impact us as humanity. If you look at WFIRST, the Wide Field telescope we're going to put up, we're working that to have a star shade that goes in front of it so that we can actually see even more of these potential planets throughout the universe. That's exciting, and then we can make some plans, right? Not in my lifetime, but we can make some plans on how do we reach out to those locations. So I think if we could, to me, our goal at the agency in the science community has always been: is there life out there? And if so, what is it and where is it, right?
Exactly.
We find that's a civilization-level impact, I think.
Yeah, I agree completely. You also make a good point, and that is it's hard to predict. And sometimes our imaginations can't even conceive of what might happen in the future. A good example of that would be, of course, that it was only 50 years before the Wright brothers flying this sort of contraption, 60 seconds, about 30 feet above the ground, 50 years between that and putting 6 astronauts walking on the surface of the moon. So we really don't know what the future holds. We only know it will be fascinating and inspiring.
And the research we're doing on the International Space Station, you never like it.
Same thing.
If we find something, we just, that's what we're working on for.
Right. Thank you, Mr. Lightfoot. Thank you,
Thank you,
Mr.
sir.
Chairman.
Fascinating questions. Thank you. Now I recognize the gentleman from Oklahoma, Mr. Lucas.
Pass, Mr. Chairman.
Okay. All right. Let's see. You know what? I went to the wrong direction. I'm sorry. I apologize. The gentleman from Virginia, Mr. Byer, I apologize. Okay.
Dr. Brad, there's so many people down there. I understand that completely. And I want to just begin by thanking Chairman Smith and Chairman Babin for holding this, and also just for the shared bipartisan enthusiasm that we have for space. And Mr. Lightfoot, I just think about following up on Chairman Smith's, with what you're doing with James Webb, with Mars, with the ISS, with the Pluto stuff, which was so exciting. We got a chance to visit with the heliophysics people out at Goddard, which is terrific. The hearings we've had on SETI, and especially thank you for the investments in Wallace. In Virginia, we very much want to be part of space. And by the way, I'd like to suggest to Chairman Smith, if you can find hyperspace and find ways to overcome the distance problems that we have in space, that would be terrific for NASA to do. It's not yet in your mission, but questions. Your budget proposes total elimination of the $100 million for the Office of Education. And I understand reading the stuff that there are issues with strategy and outcome-related data, and you need to rethink it. I'm concerned about the complete elimination of that Office of Education when everything we hear is that we need a lot more scientists and mathematicians and engineers, that STEM education has to be the heart of education moving forward. So how do we reconcile this tremendous need for more mathematicians and scientists with eliminating this office?
Yes, sir. I think one of the things that we worked on was trying to, as I said earlier, try to integrate our education outreach a little better from the overall formal program. I think that the important thing to remember is we still do a ton of education within our mission directorates. In aeronautics, for instance, we have the University Innovation and Challenges activity where we actually fund undergraduate research and graduate research to do some of our technical challenges. We have the STEM science activation activity in science that's still there. We have the NASA Space Technology graduate research or research fellowships that are still there. We have several programs still running in the missions that we actually engender folks to actually come help us solve some of the technical challenges we have. So that's another way that we actually invest in the STEM workforce for the future for us. So, and that's still all in this budget as we go forward.
Our chairman said, I'm paraphrasing, that NASA couldn't be the piggy bank for climate change research that could be realistically done by other agencies. And I looked just at the 5 that are going to be eliminated: the plankton aerosol clouds and ocean ecosystem, orbiting carbon observatory, the climate absolute radiance and refractivity observatory, the radiation budget instrument, and deep space climate observatory. All those are out in space. Is there really any other institution in the federal government that could do those?
I think for us, right, the spacecraft that we build and the ones that we put up are all part of what we think we do for Earth science, which is informing decision makers on the risk to the planet, right? There are other agencies that we work complementary with. We build the spacecraft for NOAA, for instance, and then we hand them over once they get on orbit and get operational. We work Landsat with USGS. These are missions that we do together. The 20 remaining missions we have in the agency for Earth science, we think provide the data that NASA should be providing to the decision makers going forward. So I think we have a very robust Earth science program right now going forward, and will still provide the data that we can provide.
Is the theory that these 5 out of the 25 are the least high priority?
Yeah, what we did is we did an assessment based on, if you look at the Earth, we kind of, I'm an engineer, not a scientist, right? So we took a risk management approach, the way we looked at these missions and what we're going to go do. And if you look at the Earth as a system, and it's an ecosystem that has a ton of different things that engage in what we do and how the Earth lives and operates. We took a look at that. We looked at the science value. Where can we get the data that these missions were going to get? Maybe not at the resolution or the degree we wanted. What's in the decadals, and then how are they performing from a cost, schedule, and budget performance perspective? And that's how we came up with the list that we came up with.
Great, thank you. In the 5-year budget, it's fascinating how completely flat it is. It's 19 billion, 092 million all the way out. But you figure with inflation, I think our data said 2.3%, it comes to a cumulative loss of $4.5 billion in purchasing power. So, if you look at it just a little askance, it looks like the NASA budget is actually shrinking every year over this 5-year period of time. So how can we argue that this is a long-term budget that truly reflects our robust commitment to space?
Yeah, we have concerns about the out years as well. The 18 budget is good for us, and we'll be working in the 19 proposal process to work the flat year thing, because that's exact calculations we've had is $4.5 billion in loss in buying power over the next 5 years. So we'll work that in the next budget cycle going forward.
Well, I'm hopeful that this will be something in a bipartisan. We'll be fighting for your increased budget too over this next 5 years. Yeah, thank you, Mr. Chair. I yield back.
Sir, thank you, Mr. Byer. And now I recognize the gentleman from Oklahoma, Mr. Bridenstine.
Thank you, Mr. Chairman. Thank you, Mr. Lightfoot, for being here. And I think from both sides of the aisle up here, we're very grateful for your leadership at NASA for so many years, and of course going through this transition. And the continuity that Chairman Smith talked about is important. You've provided that, and we're all very grateful for your leadership there. I wanted to bring up to start some of the processes related to earth science. You mentioned in the budget that you went through a process. You started with the decadal survey, and then the science value, and finally performance. And from that, you were able to determine that these were the missions that were the most important and were in keeping with the budgetary constraints that NASA has to adhere to. I wanted to get your thoughts on, can you assure us, because I think on both sides of the aisle, we all want to make sure we know what's happening to the planet. We can disagree about the policies that need to be implemented from Congress, but we all want to know what is happening to planet Earth. Can you assure us, given this budget, that we're going to have the science and the data necessary to know what's happening to the planet?
Yeah, we believe so. And I think the other thing that I haven't mentioned yet that I'll share is we have the next Earth Science Decadal comes out in 2017, right? So the one we're living to is 2007. Clearly, there's a lot of information since then. And so for us, it was a good opportunity to say, okay, let's see what the decadal says when it comes out, and we'll use that data actually to inform us in our next cycle if we need to make any changes from there. But I believe so. In terms of how we've assessed where we can get all the data we think we need within again looking at the Earth as a system and all the different pieces of that system. Where can we get the pieces of data that help us assess the Earth as a system?
Okay, fantastic. My second question, there was a lot of excitement in Congress, a lot of excitement throughout the entire nation. I think a lot of excitement at NASA when you made the determination that we were going to study whether or not we were going to put humans on EM1. And earlier you mentioned how important it was that when the American public, and in fact the world, when they see humans in space doing stunning achievements, that inspires the next generation. And I think there's broad agreement here as well. Can you go through the process that you went through to determine whether or not to put humans on EM1?
Yes, sir. We talked to the administration when they came in, and this was one of the things they asked us to go look at. We'd looked at it before, obviously, but we hadn't looked at it in a while. And what we did is we put a team in place I asked them to look at the feasibility. Could we technically do this? And the teams were very, just like I said, very energized in what they did. The approach we took was go back 2 or 3 years to when we made the decision to not buy crew, and look and see what things we've done that we would have to back up and back out of to redo, because now we're going to put crew. That's one example of the technical pieces. We asked the schedule, how much extra schedule would you need, and then how much extra budget would you need to do all this. It was a fascinating exercise just because it energized our teams and provided us some insight into some areas we did not know people had concerns about necessarily. And so we're going to pull some testing forward. But at the end of the day, when we had the discussion around this, we were going to increase the cost. We were going to slip the schedule a little bit, and we were going to accept some more technical risks than we had. And so it really just confirmed that the plan we were on, that we had in place, was actually a good one for us and the right one for us to go do. In the meantime, we'll go do some work on the heat shield for Orion. We'll probably advance an ascent abort test, move it forward, and some other testing that we found in the process. but it really got the teams focused on what we need to do to get there. And so it was a good exercise, and I think we had to deal with there was some disappointment that we're not going to go try to do this, but I think people recognized at the end of the day that it actually focused us even better to try to get there.
Thank you, Mr. Chairman. I'll yield back.
Yes, sir. Thank you. And I'd like to recognize the gentleman from Illinois, Mr. Foster.
Yeah, thank you, Mr. Lightfoot. And first, I'd like to congratulate you in general terms on your management of the whole unmanned science program. And this is you've been doing this in very trying times and had to make a lot of hard decisions. But I think as I guess the only PhD scientist in Congress, I'm really excited to just think about what the James Webb Space Telescope is going to mean. It's people believe it's going to be a Hubble-like step in our understanding the universe. And so I know that I and probably almost all scientists on Earth are excited to see what that will reveal. I'm less sanguine about the goals of the manned space program. In particular, the whole concept of having Mars as a horizon project, as you say. Because, when I look back at the fraction of GDP that was associated with actually paying for the Apollo program, and, the fact that it was paid for basically by having, more than 80% top marginal tax rates at the time, on the wealthy, then you have to imagine, for Congress to start planning about that and to start preparing the public for it, we have to have some sort of zero-order cost estimate for that. And so, you can imagine going to Mars with different strategies. The traditional low-cost one is a massive heavy launch vehicle, which has traditionally been the low-cost way of doing things. You can imagine the infrastructure approach that you're talking about step by step, and then you have to deal with the challenges of the operating costs for these things, for which I think, have pretty good data now from the ISS of just the order of magnitude of those. And then there are more speculative things like the robots first approach to going to Mars, which is one I'm personally a fan of. So the question is, have you gone through those exercises to get even a broad range of cost estimates for that? Because I think it's very destructive to an organization, in my experience managing things, to give a group of people orders that are impossible to execute. And I view going to Mars on a flat budget as an example of that. And so in order to make sure we have a consistent overall plan here, it'd be very valuable to even have a very broad range of cost estimates for different things. It tells you, among other things, how aggressively you should pursue new technologies if that's the only way you can get to a plausible budget. And so I was wondering, have you gone through those exercises, even in rough terms, for if you had to write down the plan today with today's technology and with specific technological innovations, what are the rough cost estimates for a manned mission to Mars?
Yeah, so we've kind of come at it from a different direction. So let me push on this. We've looked at this as we're not expecting an Apollo-like injection of funds, right? So what we've told our teams is just you need to assume what we call current services, which is basically our baseline budget that we have today plus a rate. And what we've talked about is we call it the and proposition. It's not just a heavy lift. It's not just an infrastructure. It's not just public-private partnerships. It's all that. It's also not just a robotic or human. It's both, right? Think about it. We're on Mars today with rovers, and you know that all too well. And the next rover that's going in 2020 is actually part of our human spaceflight planning because we've put an instrument on there to allow us to see if we can actually pull oxygen out of the atmosphere. So what we've been doing for the past couple of years is really integrating the science and human missions to say that anytime we go anywhere, it's an opportunity for both sides, human or science, to actually get a benefit out of it instead of stovepiping the way we're thinking about that. So it's a sustainable process, and where we've come from is, or the way we've been approaching it is, assume what you have today, and then let's see where the technologies come in. Where's private industry coming in? I mean, you see a lot of folks that are really bringing systems into play in the private world. Our international partners, we're engaging with our international partners on what they can bring, because we think going to Mars with humans is going to be it's definitely going to be a global effort. It's not going to be just us. We love to lead it. We want to lead it, and we are leading it. But I've met with the international partners twice now since I've been in this role, and looking at their niche areas to come forward like they did for the International Space Station. So that's how we've done it so far. When we bring the plan in 27, there's a plan I think we're deliverable here in December. You'll see the pieces of that. No, there
Will
was
that
not that.
include zero order cost estimate for the whole endeavor, with a given target date?
Yeah, we'll
Because I think that's fundamental to, we have to plan how to convince the public to write a great big check to do this. And so we need a zero order cost estimate, and also, as I mentioned, it's fundamental to the choice of technologies you're developing.
Absolutely, and we have unwraps for those technologies, but it'll come in, and again, our cost estimate will be based, it won't be, we need this, it'll be based on this is what we think we can do and when. So, I mean, that's what you'll see.
Yeah, and you mentioned escalation. It's in my experience managing technical projects that inflation for technical projects was generally ran above CPI inflation. And what number do you actually use internally for that?
We've been using 2.3.
All right.
Yeah.
Oh, okay.
But we've also, I think, real quick, and I know we're over on your time, but one thing I want to add is, if you look at the GA report recently on high-risk projects, we've actually shown improvement. We're not going to break our arms patting ourselves on the back here, but we've shown a tremendous amount of improvement with our program project techniques and estimates that we've done, and within the agency, to actually be better at predicting the performance of these things going forward, using a lot of lessons learned that we've had for some issues that we've had in the past. So I'm pretty confident that we can bring a number that we can stand behind.
All right.
Thank you.
Thank you very much. And now I'd like to recognize the gentleman from California, Mr. Knight.
Thank you, Mr. Chair. Thank you, Administrator, for being here. I'm going to talk about the big A because I always do. There are several things that are happening today, and I appreciate everyone talking about space exploration, and I wish Congressman Perlmutter was here so he could raise up his bumper sticker saying 2033, and all of those are great and laudable goals. But we are doing great things that are near term and can change our economy. You brought up the low boom supersonic demonstrator. I think there's probably nothing bigger that's happening right now for our near term that could change our economy. And remember, as you know, for the last 60 plus years, we've been flying across the country at 0.8 Mach, and we've been doing it a lot safer and economical, and we have been doing everything to make engines cleaner and all of that, but now it's time to go faster. Let's get across country faster, and I think the low boom supersonic demonstrator is that key that we will get there very quickly. Also, the X-57 is now moving very quickly into its stage of maybe changing flight over the future and making that a lot cleaner, and maybe for the folks to get an airplane in their yard. But one of the things I wanted to bring up is the education budget, because education to me for NASA is accomplishments. If you show something to that 8-year-old, that 8-year-old wants to be an astronaut. There is no doubt about it. If you give them a coloring book, they might. But if you show them something, they will. There's no doubt. So as I think that education is a huge part of what NASA does, the more accomplishments you do, the more you're going to get. And I think that is a good indicator of what the chairman brought up of how many people we've got applying to be an astronaut today is just because they want to be involved. And also what's been happening with Hubble over the last couple days have been huge accomplishments. So that's just my advertisement for what NASA's doing, and I thank you. So my questions are more about, again, about aeronautics. The budget has changed. We think that the budget is going in a better direction for aeronautics, but it is still a very, very small part of the NASA budget. So we're still under 4%. I think we're at about 3.6, somewhere in that range. Do you see that as a good spot? And it could be. As a good spot for where aeronautics could be or should be, or some of these programs that we could bring on board that could be funded by NASA? Do you think that maybe a little bit more money into aeronautics could get us there?
Yeah, I think with the goals we have, New Aviation Horizons, for instance, that our aeronautics team has laid out, which has so many fascinating, exciting missions in there. I think when you look at what we're trying to do with low boom, as you said, with X-57, just getting our teams back into the business of X-planes again has just re-energized them in a big way. And we think this budget is actually pretty good for us for 18. We'll look and see what kind of energy we get around low boom, and we'll look at potential future, should we accelerate other things. But when you want to tap into a $2.5 trillion global economy, of aviation, The U.S. needs to be in the middle of that, and our researchers are ready to go do that, and I think that's what we're going to be doing. So I'm excited about what the guys have done from an aeronautics perspective. You know it just as well as I do, because I know you meet with the guys a lot. And I think the energy, we talk about the energy around human spaceflight, the energy around having an X-plane program is just enormous. It doesn't get spouted as much because it's not human spaceflight, but when you talk to our teams, the ones at Armstrong in particular, they've been beating on me for 5 years to get some X-planes.
Good.
So we finally got one. And so
Good, and I appreciate you've been a good voice and a good leader in that aspect, and I appreciate that. And then the last thing I'd like to talk about is NASA as a whole. We've kind of looked at everything that's happening, whether it be James Webb, whether it be our space exploration, whether it be aeronautics. Do you see that as a very healthy position right now? In other words, from the budget standpoint, because I know the chairman of this subcommittee and the chairman of the complete committee on science, space, and technology will always talk about the budget and where we are. Are we healthy moving forward? Are we accomplishing the goals? Because now we're into a different realm over these last few years where the public is doing a lot of these things. They're doing low Earth orbits. They're doing things that NASA kind of paved the way so that they could do it. But now they're taking over some of the things that NASA maybe doesn't do or doesn't have to do. So are we healthy moving forward?
I think we've got a good balance. I think we're doing it with a risk management process that allows us to understand that balance in a good way. It's exciting to see American industry be so interested in the innovation that comes with that, because that's what makes this country great, right? The American innovation that comes in. We can enable that. And then what we're trying to do is decide where that line is, where we need to own it, and we let industry take off. And I think we're still learning that, but I think we're at a good balance. I feel very comfortable with the balance we have right now.
Very good, and I appreciate your leadership.
Thank you.
I will. I don't have any time, but I will yield to the chairman.
Thought I'd point out for fun, since we're among friends today, something that not many people know about you, and that is that Congressman Knight has a special interest in space, particularly speed in space, which was indicated by his first question, because his father set the record for speed that lasted, I think, for several decades.
Still, 50 years old this year.
Oh my gosh, 50-year record and counting then, as far as the speed of a manned aircraft. So we appreciate Congressman Knight's being on the committee, and particularly his personal interest in the subject. Now yield back.
Thank you.
And I would second those comments, Mr. Chairman. Pete Knight is a hero to many of those of us who fly. So I'd now like to recognize the gentleman from Louisiana, Mr. Abraham.
Thank you, Mr. Chairman. And let's continue the speed discussion and talk a little bit about hypersonics. Of all the things that we have to worry about for national security, we seem to be focused now, rightly so, on ballistic missiles of North Korea, Iran, those nefarious countries that want to do us harm, evidently. But hypersonics are the weapon of not just the future, but the weapons of now. And I know NASA has some great research going on with the X-43 and other X-planes that will become critically important for national security, because unfortunately at this point we can't intercept a hypersonic vehicle like we can a ballistic missile. So if you'll expound on that a little bit as NASA's roles in hypersonics and national security issues, please.
Yeah, I think what we do in hypersonics, it's for us, the part of hypersonics we're very interested in, and we think we have the skill set to support from a national perspective, is kind of the fundamental research, whether it's materials, whether it's guidance, navigation, and control, propulsion, those kind of areas that are basic in our kind of our capabilities we have. And then there's a piece of it called the systems analysis, where you can do the analysis around all those when they become a system. It becomes a flight demonstration system. So that's where NASA's strengths are in hypersonics. We have some facilities that are very unique, and we have people that operate those that clearly have the intellectual capacity that understand all the history there. So what we've done is we've partnered with DARPA and DoD in that area. And so what we do is we help them from just a fundamental research perspective, bringing the systems analysis in, and we think we're a part of their team. They've been very open to having us participate with them, and so I think that's where we think we bring to bear in that particular situation. Their job is the military side of that. Our job is the fundamental research. And the reason we're interested, I want to be real clear here, the reason we're interested is because at some point down the road, you could actually potentially use hypersonic technology to get to orbit, right?
Right.
With
And
our
to
payloads.
explore
Absolutely.
where we can't go yet.
Yep.
Literally Star Trek type technology. And you alluded to it a little bit with the intellect. We all in this room certainly understand that NASA has always employed the best and the brightest. What is NASA doing to continue that evolution of pulling those students and those young people in so that we can stay ahead of our competitors and near peers in the global security world?
I think, well, several things. We have several of the programs I mentioned earlier that each mission directorate has, whether it's science STEM activation, whether it's the university activities that Aeronautics is doing. Space technology has graduate fellowships that they do, or research fellowships that they do. So that's the direct piece of it. The other thing that we're doing, I think is really important, is we're taking a hard look at the capabilities we think we should be stewards for the nation, whether it's propulsion, mechanical systems, guidance, navigation, control, materials. Where do we need to own that, and where does the industry have that we can go take advantage of? And so we spent the last couple of years really saying these are the technical capabilities we should be stewards of.
Are you guys actively recruiting in the universities, or
yeah.
are you waiting for the students to come, like the 18,000 applicants for 12 slots of astronaut?
No, we are actively recruiting. We don't have that is an area where we do not have a challenge. We get a ton of applications. You heard 18,000 for astronauts. We get a lot for any engineering position that pops open. We are our brand does well in the universities, and so we're pretty successful.
And we're
there.
glad it does, I assure you. One last question. Previously, we in this committee have been told that I think maybe 80% of NASA's infrastructure is beyond design life. And I'm assuming that's still true, considering that the budget has remained fairly flat. How critical is that right now?
Well, it's pretty critical. But what we've done is we've put in place a pretty extensive process to look at duplication and overlap in facilities and capabilities to make sure when we give you that number is not a bunch of the same stuff, right? And so we've spent the last 3 years going through that and defining what the center role should be so that we know where to target to get out of some of the older infrastructure that we have. And we've been very successful in that so far. So the teams are doing a good job depending on each other instead of being 9 different centers across the U.S. We're an integrated system. And so that's what we're trying to do to get that down. We won't. The biggest way to get rid of the backlog of maintenance and design is to tear the old stuff down and build new stuff, right? Yeah. And so that's the way we're looking at it. And we're actually being very strategic about how we go doing that in terms of attacking the higher maintenance things first.
Thank you. We appreciate NASA. Mr. Chairman, I yield back.
The gentleman from Florida, Mr. Dunn, is recognized.
Thank you very much, Mr. Chairman, and thank you, Mr. Lightfoot, for being here. Let me, if I can, stay on the subjects of aeronautics, science, and strategy just a bit. We've had a lot of talk about the Deep Space Gateway. Can you elaborate a little bit on how that impacts the strategy for our country going forward, and maybe discuss just a little bit for everybody how that works?
Yeah, so when we talk about leaving low Earth orbit, we think we need an infrastructure, kind of a backbone that allows us to do that. So what we've been looking at is a way to very affordably, not a large system that we have to maintain. To the earlier question, what is the actual minimum capability we need around the moon to allow us to start testing these systems out? So when we talk about a gateway, we talk about an infrastructure, and it's in the concept phase. We're still working with the administration on what that will look like at the end of the day. But we believe it includes a power propulsion unit that will be built off of what we did for the ARM mission, the asteroid retrieval mission. We think we'll have a habitat. We're working right now with 5 different potential vendors on our next step BAAs to do habitat systems, habitat concepts, and then we'll have an airlock on there, and you'll be able to move this around, and you can operate telerobotically on the moon. You can use it as a place that you actually take off and go to Mars from there with a different system. It's almost a node, if you want to call it that. So,
Does it impact cislunar missions as well?
Yes, absolutely. It would allow us to move around the moon and do multiple types of missions around there.
All right, thank you very much. So what other countries are in that space besides us?
In the cislunar space? Right now, no one's there. The Chinese, I should say the Chinese are going to the moon. We know that. But what we've been doing is we've been talking to all our international partners, the same ones we have on the International Space Station today, about where they would like to participate in those exploration plans as we go forward. So we continue to share with them what we're thinking, and they bring in their niche areas that would be good for them. They actually bring, I mean, several of them bring very good capabilities to us. And so as we look at a global effort in a resource-constrained environment, you know, it's that those partnerships, whether they're international or whether they're public-private here in the U.S., are all for us things that we can use.
And last, I'd like to ask you to talk a little bit about the CubeSats that have become so popular, the smaller mission satellites, and they're launched in clusters. And then I know we're now assembling those on the Cape, right, in the center. And maybe talk to us a little bit about how NASA is going to be interacting in that space.
Yeah, this is an exciting area, I think, a very exciting area. As CubeSats and small sats have gotten, we're able to control them better. We're able to get actual science data back. We're actually using them for communications. It's a very interesting area. We have an initiative in this budget that it's a small sat CubeSat initiative where science is actually going to look at a way to get some of the data that we've been getting with big missions. Can you actually get the same kind of data, close data, from a capability perspective using CubeSats? Because we can launch them as part of another mission, right? You've seen that. We take them up to space station and we launch them from the space station out of the Japanese module. So we're learning more and more about that, and we're also getting better with the systems. I mean, the systems are getting smaller and smaller. It's amazing what you can do with these CubeSats now in terms of controlling their altitude, their attitude, and propulsive maneuvers on orbit. So that's what we think that's a big opportunity for us, and that's why it's in the science budget this year.
And are those CubeSats, are they hardened on EMP, in an EMP sense? Are they hardened against that?
Oh, I don't know. I don't think we've gotten that far yet to think about that. But,
that's
yeah.
your task.
Yeah.
No, thank you very much, Mr. Lightfoot. I enjoy your testimony. Mr. Chairman, I yield back.
Chair recognizes the gentleman from Indiana, Mr. Banks.
Thank you, Mr. Chairman. And Administrator Lightfoot, just a brief statement, not a question for you this morning. My district in Northeast Indiana is one of the largest manufacturing districts in the entire country, building everything from RVs to military hardware. We have some companies as well that specifically support NASA programs, including the designing and building of sophisticated satellite payloads for national and international weather observations. One specific program important in my district is called the Radiation Budget Instrument. It will leapfrog current technology by accurately measuring the impact of the sun's energy on the Earth and the Earth's own energy than the current generation of sensors that we currently utilize. The technology advances are critical to researchers to help improve longer-term and seasonal weather forecasting, such as seasonal tornado and hurricane forecast. There are many parts of the country, including Indiana, which will benefit from these breakthrough technologies. I understand the agency must make priority calls, but it is my understanding that the program is 80% complete. It's on track for an on-time delivery and has solved all major technical challenges. Looking forward during the budget process, I would like to work with you and my colleagues to ensure that we don't discard investments that we've already made in these next generation technologies and lose the opportunity for greatly increased seasonal forecasting, which will help our emergency managers and our agriculture and energy sectors, among many others. So I look forward to working with you and having those discussions in the future. I appreciate your testimony today. With that, Mr. Chairman, I'll yield back.
The chair will now recognize himself for 5 minutes. Mr. Lightfoot, I've heard that there might be some challenges at KSC due to a shortfall of funding for ground systems. Could you comment on that for me, please?
I think ground systems is okay from a perspective of what they're trying to do. We have some of the money that normally would be in the ground systems budget is actually in the construction budget, and when you add them together, it's the money they need to get the job done.
Okay. We both know that if everything's a priority, then nothing's a priority. And so I'm curious about a roadmap to Mars and our ability to stick to that roadmap, subject to funding, of course.
Well, I think we have a report due back, I think, to this committee in December 1st. That's going to show the plan. I believe we were asked to provide a plan of getting to Mars by 2033. And so we're working on that, and I think you'll see why we think it's actually a sustainable plan based on the budget that we've got. So I think if you look at the series of missions we're planning on doing in the 2020s with the SLS Orion combination, the missions we're talking about doing with our commercial partners to actually, provide the supplies for what we're trying to do, I think you'll see that it's a sustainable plan, and it's actually doable if we, to your point, if we'll just stick with it.
Okay. If you had 1% of our budget instead of just 0.5%, or if you could have like 4% during Apollo or something, what would you do?
Wow. I think so I think the way I would answer that question is that you see what we do today with the budget that we get.
Yeah.
Right? And I think you would just see more contributions to the scientific discovery, the exploration, the pushing humans further into space. But I also recognize that we're part of a bigger federal budget here, and I think that balance has to be maintained, and that's to me that's for you guys to decide where that balance is for us. Could we do more? Sure, we could do more. But within the other constraints we have as a nation, that to me is I think we have a good budget for what we need to go do.
Okay. Could you comment on the administration's decision not to put crew in the first flight?
Yes, sir. As I said earlier, I think that was as much our decision as it was theirs. We worked with them directly on that. We just felt that the addition of the technical risk, the addition of the cost risk, and the addition of the schedule risk actually showed that our plan that we had to start with was actually probably the right one and the right way to go. And I think, to me, it was when the teams brought all the information, as excited as we were about possibly doing it, it actually confirmed we should be doing what we're doing from an overall perspective.
It hasn't been very clear in the press, but China's been quite active on the moon, and wonder if you'd comment on that.
Well, I think the Chinese have I know as much as you do from a press perspective, but you can see they've got their first piece of what would be their space station on orbit now. They've gone to the moon. They're talking about going again. They've made some announcement this week about that in terms of a sample type return from the moon. So they're very active. I think for us, we have to decide at some point what's going to be our interaction with them from an overall perspective as a federal government, how we're going to deal with them. The stuff we've worked with them on has been mostly scientific in nature going forward, and I think we just should keep paying attention to what they're doing and make sure we're not ceding leadership from that perspective.
I think that's very important. Do you see any militarization of the moon by the Chinese?
I don't. That's probably for somebody else to answer. So I haven't, not in my world.
Do you think we're still ahead of them on efforts to go to the moon again?
I think so. I think the systems that we're putting in place are I think we are, but I don't have any insight into their systems as much as I do ours. So I'm pretty confident in our ability to do what we want to go do, and I think that's where I think we're okay from that standpoint.
Okay. Thank you very much, Mr. Lightfoot.
Thank you.
Chair recognizes the gentleman from Louisiana, Mr. Higgins.
Thank you, Mr. Chairman. Mr. Lightfoot, thank you very much for being here. This is a fascinating conversation. I was born in 1961. I have a very nostalgic memory of NASA as I grew as a young lad and observed the moon landing. And for my entire life, I've looked forward to our return to space and our return to dominance of space which we certainly seem to have lost that clear dominance as a nation as we explore beyond our planet. The history of NASA is replete with, you know, the smartest guys and women in the world doing more with less. And I'm happy to say that the current budget, as requested by the President, cuts NASA's budget. It's the lowest of any non-defense or non-security related part of the executive. And because this is a discussion about budget and NASA and what you can do, and you know, we recognize that certainly in this committee, from a bipartisan perspective, we recognize that if we're to be first on Earth, we must be first in space, and yet we must protect the people's treasure. One of the projects that I've followed through the years, is a fascinating success, is Cassini. In your written testimony, you stated that after 13 years orbiting Saturn, our Cassini spacecraft has begun a series of 22 daring dives through the 1,500-mile-wide gap between the planet and its rings as part of the mission's grand finale. That'll be in September of this year, 19 years from launch. This mission also included a lander on Titan, Saturn's largest moon, which sent back fascinating data. And it's important to note that the success of Cassini and the Titan lander was reflective of 25 to 30-year-old technology, 1980s and early 90s technology. So my question to you would be, considering the fact that this technology and the success of Cassini is that old, is pre-digital. We should note that the iPhone was introduced in 2004. What do you expect from Cassini's September end of mission controlled crash into the surface of Saturn, and what might we expect from missions developed with current technologies as we move forward, and as that relates to NASA's historic ability to do more with less?
Yeah, I think I've been in this business long enough, or in this agency long enough, to not speculate on what we might see, because we always get surprised with what we learn. If you look at the recent images from Juno as it went around Jupiter, I mean, just stunning.
Right.
And that's newer technology. Still, you know, when we launch them, it's a little older. But I think what you'll see with Cassini is this is why we're doing the dives. We want to see what's there, what's in there. We've already learned even from some of the initial passes. To me, what's happened, the reason we're able to do more with less is because of the advances in technology, right? If you look at the miniaturization, like you said, your iPhone, if you look at the miniaturization of sensors, propulsion systems, all the things that are happening, you try to pack those into a spacecraft that's going to go make these incredible discoveries. That miniaturization actually helps us, right? It helps us to be able to build these spacecraft, because to get them off Earth is the hardest part of this, you know, getting them there. So I think the technologies we're working on, whether they're new detectors, new sensors, that's what we have in our budget from a science standpoint and a technology standpoint. Both of those mission directors are working on those kind of things to allow us to get that even better kind of data that we get. New Horizons is another great example when it went by Pluto, and the stuff that we got back there. So technology is a critical piece of us. That's why we think the space technology mission director and the technology that the science mission director does is actually feeds forward into the next mission. Starshade, for instance, that I talked about earlier, is another technology we'd love to get on orbit. And again, be able to use those technologies to just do better discoveries and more discoveries. The thing that I've learned is every question we answer causes more questions, right? And that's what's so exciting about what we do from a science standpoint. And that technology helps us to actually move forward.
And just briefly, thank you for that answer. Just briefly, could you address regarding the budget as it currently begins to manifest for NASA? What's the general morale within NASA? It seems to be an exciting time of rebirth, and please address that briefly.
Yeah, you know, we're the best place to work in government for the last 5 years, and I think that probably says it the best. That's our workforce filling out the government-wide survey. People are excited. I mean, the chairman was there yesterday at Johnson. Goodness gracious, people are just they're excited about what we're doing, and they're excited because if you look at the cadence of discoveries, we make a lot of news, right? And it's usually good news, usually. And I think that it inspires our teams to actually do even more. So, yeah, I think the morale's good, very good.
Thank you very much, Mr. Chairman. I yield back.
Thank you. I now recognize the gentleman from Florida, Mr. Webster.
Thank you, Mr. Chair. Mr. Posey was asking about the money constraints, and you laid out a time frame of how you could work out a trip to Mars. Isn't that also constrained by timing? It seemed like we had testimony before about the fact that there are certain good times and they come around not so often.
Yeah, it's a cadence. You'll look at 2031, 2033, for instance, are very good times for us to go to Mars based on the orbital mechanics of where Mars is located and where the Earth is. So, I know I almost brought the bumper sticker, sir. Anyway, but I do think that there are more optimal times because of the crew transit time. If you have crew, you want to take those shorter windows. That's why 2033 is probably one of the best. I think it's a 9-month transit. I probably got that wrong, but that's what we're looking at.
You mentioned nodes, and are there ways that we can advantage ourselves with those nodes in other places like the moon and maybe launch from there? Does that change any of that?
Yeah, that's one reason we're looking at that, the kind of gateway concept that I talked about. It would be a place where you can actually operate down at the moon if you wanted to, but you can also take whatever system you want to take to Mars and launch from that location.
So wherever you get to, you're advantaged by the fact you're there as opposed to having everything one hub, which would be the Earth.
Yeah, and the way we look at it is you go back and forth from that node to Mars, and then you come from that node home with a different system. So
would the funding that you have proposed or you're going to share and the time scale and all of that, would that include taking stuff with you?
Taking stuff.
Okay, so you're going, let's say it's 2033. And you're saying if you were to launch from there, from that node, is in your plan not only to get there, but also take things that would facilitate a future launch maybe from there?
Yeah, that's the goal, right? Would be to set that infrastructure up so that you could go do that. But we're also looking at ways that we can live off the land when we get there. It's called in situ resource utilization. Today on the International Space Station, we reprocess all the moisture into water that these guys can drink, so I don't have to carry it. Water is pretty heavy. I don't have to take it with me. We've also been doing 3D printing in space. We have a 3D printer on the International Space Station that we're thinking is a kind of a precursor to what you might take with you when you go, and if something breaks.
Do you manufacture things there?
You can do your part. We're doing parts today on station using the powders that we've got. So it's pretty exciting from that standpoint. That's the kind of way we're looking at it. So it's going to be a combination of what do we need to take, but what can we also have with us.
And I guess that advances as technology
goes
yes. forward. Yeah.
Oh, yes.
Great. Yield back. Thank you.
Thank you so much. That's fascinating. Now I recognize the gentleman from Colorado, Mr. Parmenter.
Mr. Lightfoot, as always, it was music to my ears to hear about 2031, 32, 33. So let's just remember we can do this, and we will do this. And I know that a lot of the morale is high because you really are beginning to, really expand your reach and go farther and put all of that talent that you have within NASA really to work on so many different, exciting projects. So thank you for that. So how are we doing budgetarily in terms of putting the pieces together to get us to Mars by 2033?
Yeah, I think the 18 budget that we proposed here actually keeps the progress going on what we need to do that. For us, the process is pretty simple. It's use the International Space Station to the maximum extent possible to develop those systems. That really is our jumping off point. We're putting systems up there now. We've got Bigelow up there, his expandable module. We have technologies we're taking up there constantly that we think will be used for future parts of this. And then we're doing the human research that we need to understand what happens to the human body, right? So the data coming back from that is going to actually help us with as we take these longer missions to Mars. Then we think then we're going to establish some infrastructure around the moon and cislunar space. and then that'll be our jumping off point as we start going to Mars. So that the 18 budget continues those systems. We think we're pretty confident in that.
Good. Are you working with outside companies, with other nations? How's that going?
Yeah, so let's start with we think there's a lot of opportunity for public-private partnerships. We've seen a great deal of interest from a lot of the industry in this country and how they want to participate and where they're going to bring things to bear for us. So that's been very positive. Kind of building off what we did with commercial cargo and commercial crew, right? Using that model. The other piece is the international piece. We've had several. As mentioned earlier, I've had a couple of heads of agency meetings with my counterparts internationally. Mostly the ones that we deal with on the International Space Station. They're very interested in participating with us on this journey. It's going to be a global journey. We know that, and I think because when we get there, that's going to be a civilization level impact, right? Just like when we landed on the moon. And I think to me, that's going to be we did it. We as a globe. Not just the U.S., not just NASA. And I think that's what we're going to have to do. But we've got a ton of interest from them as well.
All right. So let me switch to a couple smaller programs that are particularly important to Colorado. NeoCam, something that we had talked about earlier that I was looking for it in the budget, but I'm not sure that I saw it in there. Can you tell us about NeoCam and where you are?
Yeah. So NeoCam was part of a recent set of selections. And what we decided to do is we were interested in the technology associated with NeoCam. It went a little bit further than we thought we needed from a planetary defense perspective. So we've asked them to go back and say, okay, if it just was a planetary defense satellite, could you do this? We continue to identify the potential hazardous asteroids, that we're required to go do. We think NeoCam is a tool we can actually bring to bear. But it had a science piece in it that we really wanted to go back to just the planetary defense from a focus standpoint. So we kept the guys going to develop that technology and come back, and we expect to hear about, I think in about a year they're coming back from a formulation perspective to tell us where they are. And it could be a tool that gets added to our tool chest, because we think there's also other ways to do it, maybe with a small sat, something like that, to get the same data.
Okay. And then, so it'll fall in the planetary defense category, but even at some point, maybe we put some science money into it, too, if that were
Well, the planetary
important.
defense budget is in science. So
But, you've got certain categories, and it fit nicely in that one, so let's just make sure we keep pursuing that. The last question I have is on Clario, which University of Colorado is very interested in, and I think it was taken out of the budget. Can you explain that, please?
Yeah, the Clario Pathfinder mission, which
Yes.
was going to fly on the International Space Station, that was some precursor work we were doing associated with a bigger Clario mission. The Clario mission, the bigger mission, estimated out at about $1 billion overall. So what we wanted to do is we wanted to wait till the decadal was done. There's a decadal in 2017 for Earth Science to see while the bigger mission, not the Pathfinder mission, but the bigger mission ranked on the 2007 decadal. We wanted to see what would happen on the 2017 decadal, and so that's what we did. That was the choice we made before we made that next big investment.
So we'll know over the course of the next year?
Yeah, we're canceling Pathfinder. We proposed to terminate Pathfinder.
Okay.
And what we'll do is when the next decade will come out, we'll see where those particular science objectives, where they rate, and re-look at the whole portfolio from Earth Science.
All right. Thank you for your testimony, and thank you for your service.
Thank you.
Thank you. Now I recognize the gentleman from California, Mr. Rohrbacher.
Thank you very much, Mr. Chairman, and I apologize going back and forth between hearings, so if I ask a repetitive question, I apologize. We just heard that we are spending money for the tracking and characterization of near-Earth objects. Is there anything in place if we do discover a near-Earth object heading towards us? Do we have a procedure in place that would then be activated in order to, in some way, deflect that near-Earth object if it threatens the planet?
We don't have anything that we're building to deflect it at this point. We've got a defense coordination office, that does all the notifications to everyone if we see something coming. But we'd have to see what we would do at that point. We're not building anything related to that.
Okay, I would suggest, Mr. Chairman, one of the things we need to do is to insist that we actually have, if a near-Earth object is spotted coming to the Earth, could kill millions of people, if not even worse, that we should demand someone, whether it's NASA or whoever, actually have a system where you say, punch the red button, it's time to go on this particular emergency. We need to do that. Now, let me ask you about space debris. We know that we've got, there's lots of examples. I mean, with the debris shield, I mean, was it last March was floated away from the space station. It was a debris shield. So we know that debris is actually causing some problems already. You know, the space shuttle was postponed a couple times for space debris accumulation. Do we have anything in place where we have a plan that will, in some way, deal with that problem, meaning to remove space debris?
Yeah, so obviously micrometeorite debris and other debris up there is actually our #1 risk for our human spaceflight missions in terms of the area where they are. And so we track it. We have a great system for tracking it, as you would say. What we've been working on in the agency is simply, we haven't worked on any systems to go remove it. We've been working on some of the technologies that might be able to do it. But it's a very low-level effort. I don't want to imply that it's a big effort, but that's what we've been doing.
Well, I would suggest that because it threatens the viability of our entire system, I would hate to think that if we're spending, by the way, what is the going to be the cost of the SLS rocket in the end per rocket?
Let me get back to you on that number. We just only because we just finished an activity that they're briefing me on next month.
Is it going to be over $1 billion?
I haven't seen the number, sir, honestly.
All right.
So,
okay. Well, let me just note that my guess, if we're spending several $1 billion a year now, these rockets are going to be phenomenally expensive. I would hate to think of a little bit of space debris coming along and negating $2 or $3 billion worth of spending on an SLS rocket. So I would think those are, whether it's planetary defense, we ought to have a system in place. We ought to get serious about space debris before space debris starts hemming us in so much that it's put restrictions, costly restrictions, on our own space program. I would think that this should be an international effort. And have we had any type of international meetings on space debris?
I think there's several things in place that we're required to do, like deorbiting second stages and things like that that are discussed internationally.
But we haven't had some sort of a major meeting where people get together and say, what can we do to clear space debris as an international effort?
Not that I know of, unless we've done something through the UN COPIA stuff. I'd have to, but I'll get back with you on that one. I'll certainly take that one for the record and let you know.
And finally, let me just note about earth science. There are so many other people that can analyze what's going on the Earth. I don't see any reason why we should turn. I love the Hubble telescopes and the various things that are aimed outward, but I have no reason to believe that people in NASA have any more expertise at trying to study what the Earth is about. They're supposed to be out studying what the universe is about, and I would think that we should, Mr. Chairman, move away from funding of Earth science missions and start focusing on the real mission of NASA, which is the missions who are aiming into space. Thank you very much, Mr. Chairman.
Thank you for that line of questioning. Mr. Vesey, gentleman from Texas.
Thank you. Thank you very much. And wanted to ask a question about human space exploration. And under the funding level proposed for exploration habitation systems, when could NASA expect to have a habitation system operational for use on an exploration mission, and what will that habitat actually be used for?
Yeah, so I think the way we're looking at it now, we've got a process in place called our Next Step BAAs that are looking at what habitation systems could be available for us from we've got 5 different companies that are working that with us. The habitation module based on our current plans would fly roughly in the middle of the 2020s. It would be located somewhere around in the vicinity of the moon so that we could actually use that area there going forward. It would have the systems in it. We would hope to outfit it with the systems that we would need for a longer-term journey, so we can test those systems out there as well. So that's what we're looking at.
Okay. As far as the CASIS key accomplishments for this year regarding broadening the use of the ISS National Laboratory, can you just go over what you think some of the key accomplishments are?
Well, I think CASIS has done a great job in terms of bringing some of the critical research, whether it's rodent research, that we do to understand the effects of medications or space travel on rodents. The CASIS team has done a great job working with researchers there. They've been bringing different CubeSats up, different things that they're working on to get us more scientific data when we actually deploy from the International Space Station. They're continuing to really develop that market, if you want to call it that, the people that can actually come up there, whether it's scientific research, medical research, or just the other deploying of CubeSats from the station. So they've done a really good job as a partner for us on that.
Oh, good, good. What about progress that you think NASA has made in just helping, retire, mitigate some key risks that are associated with human exploration in deep space?
Yeah, I think to me that those key risks kind of fall into two categories. It's the risk on the human, and it's the risk on the systems that we need. So we're continue to work in our Space Technology Mission Directorate on some of those key technologies, whether it's entry, descent, and landing, whether it's radiation protection, those kind of activities. On the station itself, we're utilizing the systems that we have. If you think Scott Kelly did the one-year mission, right, to understand the impacts of somebody being on station for a year as opposed to 6 months. So we've got a list of human research things that we'd like to do on the International Space Station before we start pushing out further. And we've got some technical things with life support systems, radiation protection that we're working on. And we continue to work on those, and they're supported in this budget.
How do you think adding a fourth member aboard ISS will help mitigate some of those risks?
Super excited about that, because by having 4 members doing the research that we do, we expect to really increase the production, because operating the station takes some of their time. Now we'll have somebody that can really be focused on the research, and we've got lots of research up there because of the resiliency of our transportation systems now with the commercial cargo guys. We're getting a lot of research up there for these guys to do, and so having an extra crew member will be outstanding for that.
Do you think that NASA is confident that all of human exploration health risks will be retired before the ISS is decommissioned in 2024?
Oh, wow. All is a big word.
Yeah.
I don't know if we'll ever have all our risk retired on anything we're doing. I think the way we look at risk is we manage it from a perspective of the critical ones. I don't think we'll have the critical risk retired, but we'll know what we need to do when we're in cislunar space to mitigate those risks going forward.
Thank you. Thank you, Mr. Chairman. I yield back.
Yes, sir. Thank you very much. And I want to ask one quick question here, Mr. Lightfoot. Should NASA be responsible for regulating private sector planetary protection standards? What would you say about that?
I think we would like to be engaged in that conversation. I think we have some expertise that we can bring to bear there. I don't see us so much as a regulatory agency as one that should be consulted. That's the way I look at it.
Yeah. So that's kind of a yes.
Yes.
Yeah, I think as long as we would love to play a consulting role in that particular activity.
Okay. All right. Thank you very much. I want to thank the witness today for his testimony, very valuable, very interesting, and thank the members for their very insightful and interesting questions as well. The record will remain open for 2 weeks for additional comments and written questions from members who may want to ask something additional. So with that, this hearing is adjourned.
Thank you, Mr. Chairman.
Yes, sir.